In this training video, we are going to show you a live coding example. We are going to illustrate working of the guideline keep units short in practice. And this live coding and also the following live coding examples, we are going to go through more or less the same routine. So first, we are going to look at description of our task. So there are going to be one ticket in Jira, an issue tracking system, describing what we need to do. Then we're going to analyze existing code, because this ticket will explain that we need to do some modifications or extensions of existing code. Then we're going to make these changes in existing code to implement our ticket. Then we're going to look at tests. So first, to run existing tests to see if we have not broken existing functionality, and then also add a few tests to test our new functionality. In this case, also covering automated test guideline. Then, if we have tests successfully running, we're going to go back to the code and see if it violates the guideline. And if it does, we're going to refactor it so that it gets compliant to our guideline. And after that, we're also going to look at code for some opportunities to clean up the code. So basically also applying our write clean code guideline. So what is going to be our task in this live coding example? In this case, it's going to be adding support to validate 13-digit ISBN numbers. So we're going to start with an example where there is already some code for 10-digit ISBN numbers, and our task is to extend this functionality with ability to also validate 13-digit ISBN numbers. So now that we know what we need to do, let's go to the code and do the actual work. So to recapitulate, what we need to do is to extend the basic functionality of validation for ISBN numbers. If you don't know, ISBN numbers are numeric identifiers of book, and basically every published book has one of these numbers. The problem is, of course, as with many numeric systems, is that you have multiple versions, and it also applies to ISBN. So there are ISBN versions with 10 numbers as well as with 30 numbers. So our task is to extend the existing functionality that validates 10-digit ISBN numbers with ability to validate 13-digit ISBN numbers. And ISBN standard defines exactly how you should do it. So this is the existing code, a little bit simplified to make this exercise easier. So what we have here is ISBN utils class, and there is one utility function or method called isValidISBN10. So this is our starting point. What also we have associated with this code is a unit test class. So this is the class that tests the functionality of ISBN utils. And you here see there are two methods. One is to test valid ISBN 10 numbers, and the second is to test invalid ISBN 10 numbers. So what's good about this unit test is that it's also very nice documentation about what this method should do. So in this case, for one example of a valid ISBN number, it should return true. And for an example of invalid ISBN number, it should return false. So let's first, before we go back to code, see if this is actually working. So we can run these tests. And we can see that all tests are passed. That means that these tests are valid and the functionality currently works as it was originally intended. And it's also good because now we also have a safety net to change the code without breaking the existing functionality. What we also have in this project is check style definition. So check style is a tool that enables you to do some code analysis. In this case, for our writing short unit code, this tool enables us to actually analyze code and see if method lengths are 15 lines or less. And I can now also go to this code, to our implementation code, and check current file. So this is analysis that's going to use this definition. And I can see there are no found problems. So it means that this unit complies to all defined check style guidelines. So it is less or equal 15 lines of code. So this is our starting point. So we have well-functional code which is compliant to maintainability guidelines. And now we need to change it to get into implement functionality and also leave it in state that is well-tested and compliant to maintainability guidelines. So our task is to extend the functionality to be able to test 13-digit numbers. The first things that I'm going to do is then rename this method, because this name of the method now does not anymore reflect what the method should do. So I'm going to refactor it and rename it to isValid ISBN 10 or 13. So this kind of explains now that this method can be used to validate 10 and 30-digit ISBN numbers. Now I need to add actual logic. And first I'm going to create outline of this method. So originally this method returns false if ISBN length is different than 10. But now we have to have two cases, 10 and 11. So I'm first going to change this structure. So first I'm going to say, if ISBN length is 10, then I need to do original logic. So this is what we should do. But now I need also to add special case for 13. So in else, if ISBN length equals 13, then I need to add our logic. And otherwise, I need to return false. So this is basically outline of our new functionality. So first, if ISBN length is 10, do the original functionality. If it's 13, do our new functionality. In any other case, return false. So I already did research about how ISBN 13 numbers need to be validated, and I'm going just to type code here, briefly explaining what it does. But in essence, the logic is very similar to validation of ISBN 10. So we need to calculate sum using some simple formula and then check if the modulus of this sum with some number equals 0. So I'm going to create variable, initialize it, sum, initialize it to 0. Then I'm going to go through all the characters in the ISBN number. So in this case, for int I equals 0 until it's less than 13. So there are 13 numbers in our ISBN number now. So I'm going to get actual character. And then add the sum result of simple formula. So I'm dividing index by modulus 2. And if this is 0, I need to get 1, otherwise 3, and multiply this with numeric value of our character. So for this, I'm using utility function get numeric value of character C. Of course, this is standard algorithm for calculating sums for ISBN 13 numbers. So what we get here, initialize variable, and then for each character, apply the simple formula and add the result of this formula to this sum. And now, similar to our original functionality for 10-digit numbers, we need now to check if the sum, in this case modulus 10, equals 0. And if the sum modulus 10 equals 0, that's valid ISBN 13 number, so we then need to return true. And otherwise, we need to return false. So this is basically what this method should do. In this case, of course, when you do actual implementation, you need to do some more work to do research how this should be implemented, but I already did that. So what we now need to do is to make sure that this actually does what it should do. So how are we going to do it? We are going to then to write a few more tests, then also check this new functionality. So I'm going back to the test class for this utils. First, let me rerun the existing tests to see if old functionality is still working. So that they are working. So all tests, existing tests are passed. So it means that functionality for testing 10-digit numbers is still correct. Now let's add similar 2 more tests, one for testing valid ISBN 13 numbers and the other one for testing invalid or functionality for invalid ISBN 13 numbers. Create new method, test valid ISBN 13. So if you remember, in our ticket in Jira, there was all the examples given with valid and invalid numbers. So I'm going to type over these numbers here and test them. So I'm going to create one variable and initialize it with value of correct ISBN number. In this case, it's 9781491940662. So this is a number from our ticket saying this is the correct number. And what our function should do is it should return true for this number. So I'm going to write assert true statement. And call our ISBN utils get valid ISBN 10 or 13 numbers with this 13-digit example. Now let's run this test. So you see this test is working, which means that our functionality is correct for this case. But we also need to make sure that this function is not always returning true. Also create test with invalid number. So I'm going to create new method test invalid ISBN number. Similarly, create a variable and initialize it with the value that I found in the ticket. And this is 9781491940664. So this is our illustration of a number that's incorrect. And now what our function should do, it should return false for this number. I'm going to write assert false and call ISBN utils is valid ISBN 10 and 13 with this. So this should be false. And now let's test this one, run this test. And this test passed as well. So now what we have showed with this is that our new implementation of this method have achieved 2 goals. First, we added new functionality, and this functionality works according to specification that we get in our ticket. So it returns true for correct number, and it returns false for incorrect number. And it also has not broken the existing functionality, because this method now can test 10-digit numbers as well as new 13-digit numbers. Now let's go back to the code. So we functionally have achieved our goal. So this works as it should. But now let's see if our code is as it should be in terms of maintainability guidelines. So let's rerun again our check style analysis. And now you see there are some issues, and we are now focusing on writing short units code. So basically, the second warning or message says that our code does not comply anymore to write short unit code guideline because we set a value to 15, but now we have a method that has 27 lines. It has almost twice as many lines as our guideline suggests. So now we need to do something about it. So we need, and the approach that we're going to use here is to split this complex unit, long unit, into few smaller ones that are being called from this one. In this case, this unit actually has natural splits and different parts. So you have one part for 10-digit numbers, which is completely independent from parts for 13-digit numbers. So in this case, we can here apply extract method refactoring and extract code in each of these separate sections in separate smaller units. And that's what I'm going to do. So I'm going to select the code in the first block and then go to the refactoring option, extract, and then say extract a new method. And how I'm going to call this method, basically similar to the original one, so it is valid ISBN 10. So this is valid ISBN 10. So this is just a piece of code, smaller unit, which tests only if the number that you get is valid ISBN 10 numbers. And I'm going to apply the same technique for the next block, so the first 13-digit part. You can select it, go to refactoring, extract method, and this is going to be is valid ISBN 13. So what I now got is a new situation where instead of having one very long unit, I have 3 units which are much smaller and which also have a number of advantages in terms of maintainability. First, it is much easier to understand and localize a part of code that you eventually need to change. For example, here, the logic of this is outlined on a high level. So what you do is you check the length of ISBN and then do ISBN 10 specific logic. Then you check for 13 and do ISBN 13 logic. And otherwise, you return false. And now you know if you need to change part of this, you don't need to understand. For example, if you need to change logic in number 13, you don't need to understand number 10. You can just zoom in and go directly to this method and make here localized changes. Now let's run again our check style analysis. And now you see with this simple refactoring, we have achieved our goal. So we have now again functionality that does what we should do, but also code that is compliant to our guidelines. Just to make sure, because each refactoring is changing some code, we can also go back to test to see if our original functionality is working after this refactoring. And you see all tests are passed. So basically we have functionally equivalent method, but a method that has a number of advantages from maintainability. So now we finished more or less our task completely. So we add new functionality, we add tests, and as a last step, we are going also to look for some opportunities. Can we make this code even more cleaner? So how you write clean. And this is relatively simple code, so there are not many complicated things here, but there's one issue here that is actually interesting and it can be simplified, and that's this construction. So basically what I have here is an argument of if I have Boolean value, and then if it's true, I'm returning true, and if it's false, I'm returning false. This can be written much simpler, so just to return this value, because this value is already going to be true or false, and now we get three lines less to do the same. And we can also apply this rule to our second example. And then instead of testing Boolean value and then returning true if it's true and false if it's false, simply return this value. And now I have, again, the similar code, but which is now smaller, even more easier to analyze and read because you have less lines of code. And again, I can go back to tests just to make sure that this has not affected the functionality. Tests are still working, so it's fine. So this is all that we need to do here. So to summarize, we started with a task to change an existing version. I saved here separate copy. So the starting point was an existing code that validated ISBN 10 number with some tests to test this functionality. We then add and extended this method to test ISBN 30 functionality, creating within the same method separate blocks of code, one being specific for 10-digit numbers and the other being specific for 13-digit numbers. We also add a few tests to test this new functionality. Then we also noticed that this new method is much bigger than it should be according to our guidelines, and we applied extract method refactoring to extract these blocks of code in separate methods, which are being called from our main method. And after that, we also looked at the code to look for opportunities to clean it and identified one of them. That's basically ability to simplify if statement and return the Boolean value instead of testing it. So that's all in this example. And in next section, we are going to go to our next guideline, which is about how to write simple units of code.